Jumbo. So far we've looked at ionic bonding, then we've looked at how we write formulas for ionic compounds. Now we're looking at how we name ionic compounds. You might think it's going to be super easy, and it is largely easy, but it's also easy to make some mistakes. So we're going to try to cover a lot of different examples so you can avoid some hiccups. So we write the name of the metal. The positive ion always comes first. If it's ammonium, we just write ammonium. If it's a multivalent metal, we have to put the charge in Roman numerals. So if it was zinc, zinc can only be 2+, so I just write zinc. Sodium can only be 1+, so I just write sodium. But if it was something like gold, I gotta say, is it gold 1+, or is it gold 3+? Is it lead? Is it lead 2+, or 4+? I have to say which one. The calculations we'll get into later. If it's multivalent, you got to calculate the charge. Number 2, you have to look at the nonmetal. If it's just a nonmetal by itself, not a complex ion, you change the ending to "ide." So fluorine becomes fluoride, bromine becomes bromide, oxygen becomes oxide, nitrogen becomes nitride. That should be done for you already on your periodic table of ions. If it's a complex ion that's negative, all you do is write the name from the table of complex ions. So it's really easy. So let's get to some examples here. Na2S. So I go, hiya, and I chop it like this. And I see, whoa, Na, that's sodium. S would be sulfur, but now it's at the back end all by itself, so it's going to be sulfide. And I didn't have to put any numbers in. That's it. Sodium sulfide. What I'm trying to do is put in the minimum amount of information in the name that will allow me to work out the formula later on. So we start with an easy one. Let's see how we do in this one. Now we go hiya. So we have mercury and we have selenium. Mercury is multivalent, so I'd write down mercury and put in some brackets. And selenium is going to be selenide. But I have to work out the charge on the mercury, and it can be +1 or +2. I'm going to work out that charge from the selenium. It turns out to be mercury 1 selenide, and you might say, well, why is that? Well, I could write it out like this. I could go H, G, H, G, Se. This is what shorthand form. And when I write the charge of mercury, I'm writing the charge on one atom of mercury. When I look up Se, I will see it has a charge of 2-. And that means these two mercuries together have to have a total charge of 2+. And that means each mercury is 1+. And so then I carefully take that 1 and I put the charge on the mercury like so. So that's my fast way of showing it. And here would be the English way of showing it, where you write it out in 3 sentences. Selenium has a 2- charge. The 2 mercury atoms have a total of a 2+ charge, so each mercury has a 1+ charge. I prefer this way. Now we look at Fe2S3. We know that's iron. We know sulfur becomes sulfide, but we also know iron is multivalent. So if I'm writing this out, I'm going to get Fe, and then I'm going to have Fa, and then I'm going to have S, S, S. 2 Fes, 3 S's. Now, each S is 2-, and 2-, and 2-. So that means this is, one of my better 6's, 6-. Oh, that's awful. So the two irons have to be 6 plus. We split that evenly two ways. So 3 plus and 3 plus. Each iron is 3 plus. So that's why we get the iron 3 sulfide, and that 3 is one. That's supposed to be an arrow. So anyways, that's where the 3 comes from. It's the charge that we've calculated for the multivalent beast. And there's our long-winded way of saying it. Blah, blah, blah. 6 minus charge from the 3, canceled by the 6 plus charge, because that's what we're doing, Ionic. We're balancing out the charges. And then we divide it by 2. Got a 3 plus charge. V2SO45, vanadium's multivalent. And we get vanadium 5 sulfate. Sulfate's 2 minus, so we can see the 2 came down there. And the 5 plus charge from vanadium came down outside the sulfate. So we have NH4, HCO3. Now this one's tougher because we actually have complex ions and we got to know where it splits. And it actually splits right here. So here's our NH4, complex ion, HCO3, complex ion. NH4 is going to be ammonium. Now HCO3, for whatever reason, students often don't find it in the chart. But it turns out you can call it bicarbonate, and I would call it that, because that's faster than writing out hydrogen carbonate. So this is ammonium bicarbonate or ammonium hydrogen carbonate. Either is correct, but bicarbonate's faster. So more popular. So ammonium bicarbonate.